All right, so there's one more thing to talk about with respect to alternating series, and that is, yeah, but I don't want to write out all the terms. And if I don't want to write out all the terms, how close does what I write down come to the actual retail price? And that is what this particular screencast is all about. And the key thing to take away from this screencast is that the error when approximating the infinite sum with the finite sum. Let's just be clear. This has infinitely many terms. This has finitely many terms. Here we only write out k of the terms. The error when approximating the infinite series with a finite series is less than the first term you leave out. The first omitted term. If you stop after k terms, the error is less than the first omitted term. And this principle is based on the back and forthness. If you were to go as far as the k plus 1th term, that would be too far. You would pass by the sum. So what does that mean? If we approximate the sum of the -1 to the n plus 1, 1 over 3 to the n, that's 1/3 minus a 9th plus a 27th minus and so on, with the sum of the first 10 terms. What's the error? If we approximate the infinite series with the sum of the first 10 terms, what's the error? Well, the error on 10 terms is less than the 11th term. It's less than the 11th term. But what's the 11th term? It's 1 over 3 to the 11th. And that's 0.00000564550. So whatever number we get by writing out the sum of the first 10 terms of this sequence, we are no further away than this from the actual answer. We're good to 4 decimal places, and that's really good. We could ask the question the other way. How many terms would we need to approximate the sum of the 1 over n squareds within 0.0000, too many zeros, 4 zeros and a 1. 1 over 100,000. We clearly don't want to write out all the terms. There are just so many of them. So how many of them do we need to get this close to the actual retail price? If that's as close as we need to get, how many terms do we need? Well, the error on n terms is less than the first one we leave out. Well, what's the first one we leave out? This is the first one we leave out. And we want this to be less than that number. So we do a little bit of algebra, and we figure out that n has to be bigger than 315.228, blah, 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 blah. So if n has to be bigger than that, How many terms do we need? We need 316 terms. Obviously, if we take more than 316 terms, we are also still within that error bound, but we need 316 terms to get that close. So try it. Uh, let's try it. How many terms are needed to come within 0.00001 for e to the n over n factorial? And this is pretty straightforward in that you can't do this algebraically. You've got to use your machine for this. So we're looking for the first one of these that's less than that number. And when we find the first one of these that's less than that number, then that's the first term we can leave out. And it turns out that 15 terms are needed. The 16th term is the first term that's less than 0.00001. Okay, there's not a whole lot of ways to ask this question. We can ask it how many terms are necessary. We can ask how close does this come to the actual sum. Those are the only ways I know of to ask the question, and I hope that these are good ways for you to look at it.